Today we are going to see the derivation of relativistic momentum. So this is connected with the Einstein mass energy relationship, E is equal to mc square. So relativistic momentum is defined as the conservation of the momentum holds in the inertial frames. So both inertial relativistic momentum and classical momentum are conserved. So we know that this relativistic momentum can be derived from the classical momentum. So P is equal to, we know P is equal to mv. P is the classical momentum. And m is the mass. P is the velocity. Now we can replace the m by relativistic mass. That means rest mass m equal m0 square root over square root of 1 minus v square over c square. So P can be written as m0 square root of 1 minus v square over c square and v. Now I want to multiply both sides by the term c. The value will not change. So I use it for in red color. So both sides I multiplied by c. What is c? C is the velocity of light. C is the everyone knows that it is 3 times 10 power 8 meter per second. Okay, now we can square both sides so that we can remove the square roots of sign, that means radical form in the denominator. So P square C square will be equal to M0 square V square C square over 1 minus V square over C square. Now there's a small adjustment we have to do. In this term, I want to multiply and divide by C square. The value will not change. So on simplification, so we can consider this as a relativistic momentum P or this one. So now it is P of square C square will be equal to M0 square V square C power 4 over 1 minus V square over C square C square. Now what I have to do? I want to do again another manipulation. So just add and subtract M0 square C power 4 over 1 minus V square over C square minus M0 square C power 4 over 1 minus V square over C square. Just I add and subtract, the value won't change. Now I can further simplify. So I can take the value of M0 square C power 4 over 1 minus V square over C square. So what will be inside here? So 1 V square in the numerator, and here the denominator there will be a C square. So m square C power 4 V square 1 minus V square over C square times C square. So this term, there's one more term here, the same term, m0 square C power 4 1 minus V square over C square. So the sign is minus. So negative 1 plus this term m0 square C power 4 1 minus V square over C square. Now I have to replace this. 1 minus V square over C square should be replaced. Just I split them both. So P of square C square will be equal to, I take the negative outside, negative of m0 square C power 4 over 1 minus v square over c square, and in this case negative sign is outside, so this will become plus 1, and this is we need plus, so already negative is there, negative times negative plus negative times negative minus, so this plus will change into minus b square over c square plus m0 square c power 4 over 1 minus b square over c square. Now you can see 1 minus b square over c square, 1 minus b square over c square, that cancel. So what we have now? Negative m0 square c power 4 plus m0 square c power 4 1 minus b square over c square, which is equal to pr square, that means relativistic momentum square c square. We know that relativistic energy ER equal m0 over m0 c square over square root of 1 minus v square over c square. So what is ER square? This gives us ER square will be equal to m0 square c power 4 over 1 minus b square over c square. So this is nothing other than this term. So you can write as pr square c square will be equal to negative m0 square c power 4, this term m0 square c power 4 over 1 minus b square over c square can be written as ER square plus ER square. So if you want, PR C will be equal to ER square minus m0 square c power 4. So I write the C correctly. It looks like it's something. C. So this is the final answer for us to find the relativistic momentum. So this is the equation PRC equal ER square root of ER square minus m square c power 4. If some cases there's a condition available, if ER is very greater than m0 c power c square, then in that case PRC will be equal to just ER. This is only in this condition, and normally this is the general equation. Thank you for watching my video. I explained everything very correctly. So step by step. Waiting. See you in the next video. Bye.